Today's lesson is about exploring transformations, and we will be looking at how these transformations affect line segments and angles. How do you know you are looking at a transformation? Well, in this lesson, you will learn about transformations by looking at what happens to a figure's line segments and angles before and after the figure has been translated. You will need your note sheet for this. We need to get some vocabulary under our belts in order to have good conversations in this unit. And so we're going to talk about pre-images. Pre-images, those are always going to be the original figure. So if you think about your ELA, pre means before. So this is the image before anything has happened to it. An image. Something has happened to the pre-image. It has been translated, rotated, reflected, dilated, something. This is the after. Now, when we are talking about figures, we will label the vertices. And so the vertices are the corners. And so you'll always know which one is the pre-image because it will have the A, B, C. So these are my pre-image corners. On the other hand, if you see these little apostrophes, these are called prime marks. So this means that this is the first image of point A and the first image of point B and the first image of point C. So these are the corners of the image. If, for example, I had done 2 transformations, I would have 2 prime marks. Or if I did 3 transformations, I would have 3 prime marks. All right, and then finally, let's talk about rigid transformations. Rigid transformations means the image has exactly the same size and shape, and those are the ones that we're going to focus on today. Rotations, reflections, translations. The only one that's not going to fit into this section are dilations because they would not be the same size. So let's start with translations. As I said, there are 4 ways to transform a figure. Only 3 of them are rigid, and the first one we're going to talk about is a translation. So a translation involves sliding. When you were a little person, it might have been called a slide. And so you're going to slide the original or the pre-image to a different location. The new image is congruent to the original because it is the exact size and shape. So you can move it, slide it, transform it horizontally, vertically, diagonally. All the corresponding sides and angles are in the same relative position from pre-image to image. When you are describing a translation to me, you will have to give me 2 pieces of information. First, you will need to tell me which way are you translating? To the right, to the left, up, down, and how much? To the left, 9 spaces, up 4 spaces, or a combination of the 2. Here's a picture of what I'm talking about. So we have our pre-image up here. And I knew that because my corners don't have any prime marks. And so here it has been slid to a new location. Prime mark A, B, and C. Now notice that corner A and corner A prime in both images is the bottom left. And B prime is the top corner. And C prime are the lower right-hand corner. All of these sides and corners are in the same relative location before and after the translation. So to move from the pre-image to the image, this figure had to be translated down and to the right. There is a common misunderstanding when it comes to translations, and so some kids think that just because 2 figures have the same size and shape, that they have to be a translation. Well, sometimes other things are involved. So when you translate a figure, every line segment and every angle is in the exact replica of the original in the same relative position. For example, if you look at these two pictures, they are not translations. They might fool you. Your first instinct might be to say, well, obviously this has been translated up and to the right. But now that you're being a little more careful and you're paying attention to details, notice the green side went from being the top to being the bottom. That's not the same relative location. Or the blue side went from the bottom to the top. So in this case, this is not simply a translation. It's not pure. It's actually a translation and a rotation. So be very, very careful. In my second example, obviously something has happened. Yes, it has moved. It has slid. But that is not the only thing. It is not a pure translation. It has slid and rotated. Another way to transform a figure is to use a reflection. So a reflection involves flipping. So when you were a little person, you probably heard flip instead of reflection. So it flips an original image over a line of reflection. The new image is congruent to the original because it has exactly the same size and shape. And you always have to pay attention to where our line of reflection is. Knowing where your line of reflection is actually a critical part in being able to describe your reflection to me. So you will tell me that a figure was translated over the x-axis or over the y-axis, over a line, whatever. So we will practice knowing what your line of reflection is and being able to name it. Your line of reflection could be anywhere. And let's look at this first example. So my line of reflection is vertical. And notice I have a pre-image on the left and an image on the right. I can tell that a couple ways. First of all, it's labeled. But also if you look at your vertices, my prime marks are on the right-hand side. Now there's something interesting here that we need to pay attention to. The distance between, let's say, point A to our line of reflection has to be equal to the distance from A prime to the line of reflection. Same thing for B. If B is, say, 10 points away from the line of reflection, then B prime also has to be 10 points from our line of reflection. Same thing for C. Let's say C is 2 points from our line of reflection. C prime should also be 2 points from our line of reflection. If we look at our next example, in this case we have a horizontal line of reflection. But we have the same thing happening in our purple arrows. Each point of the pre-image is exactly the same distance to our line of reflection as every corresponding point on our image. That leads us to our common misunderstanding. I don't want you to be fooled. I'm going to try and do it. Just because the image is mirroring the pre-image doesn't mean it's a pure reflection. Make sure you check the distance each figure is to the line of reflection. If those distances do not match, the figures are not a pure reflection. What they would be a reflection and a translation combination. As I said earlier, a reflection is a rigid transformation because we're going to get an exact replica. When you reflect a pre-image to an image, you create an exact copy. Segments are still taken to segments and angles taken to angles, only now they are going to mirror each other. So if you look at these, the locations are interesting. Our blue side stays on top. Our green side stays on the bottom. our yellow side, which is closest to our line of reflection, stays closest to our line of reflection. And I think this is supposed to be a brown side. Our brown side, which is furthest away from our line of reflection, stays furthest away. Our final rigid transformation is a rotation. And so when you were a little person, it was probably called a turn. A rotation involves turning an original image, either clockwise or counterclockwise, around a center of rotation. The number of degrees that you are turning the figure is the angle of rotation. The new image is congruent to the original because it has exactly the same size and shape. When you are describing a rotation for me, you will need to give me 3 pieces of information. You will have to describe the direction. Oops, that's an I. The direction, and so that's either clockwise or counterclockwise. You will have to tell me where is the center or the pivot point, and you will have to tell me the angle or how much I am going to rotate the figure. Let's talk about some of these vocabulary terms with a picture that might help us a little bit. And so we're going to start with our center of rotation right here. And so I want you to pretend that you have a pencil and you're going to stick it right on the center of rotation. And then you're going to take A and you're going to turn it on that pivot point. Your pivot point is your center of rotation. How much you plan to move it, that's the angle. And so you have your pencil stuck on your pivot point, which is your center of rotation, and you simply slide like a clock hand would slide, counterclockwise A onto A prime. Corresponding sides and angles are a bit trickier here. We have to pay attention to the lengths of the sides to help us out. They will still be in the same relative position within the figure from the pre-image to the image. We have a common misunderstanding with rotations as well. Some kids believe that because this is called a center of rotation, that it has to be the center of the figure, and that is not true. A center of rotation can be anywhere inside of, outside of, or even on the figure.